Melanie, why are you in my room?
Zainab, I need help.
You need help with what? Why are you in my room at 7:10 in the morning?
I'm gonna get 4s on everything. I have to reassess 14 standards in 2 days and I don't know physics.
I mean, I can't help you with that. I have a bi-weekly experience.
Zainab, what the heck? We need to do something.
We have an SAT in 6 days. How are we gonna reassess?
We need to make something. What can we do?
Maybe we can film a video and see if Mr. C will take that.
Zainab, you know the project is due in 3 days, right?
What?
We didn't even do our individual one yet.
My research papers do. Hey Mel, can you pass my phone?
Yeah.
Well, wasn't that physics or something?
I think that was projectile motion.
Wait, we can talk about that in our video.
Yes, perfect.
As you can see here, the ball started from rest and fell at a height of 2 meters.
Okay. So for the topic of projectile motion, it's a good idea to make an XY chart to start. So before, Zainab said that we had a starting height of 2 meters, and the acceleration is always 10 meters per second squared, and the ball starts from rest. So what we don't know is the VF for the Y, and then the delta X for the X value, and the V for the Y, the X value. So we're gonna find it. So these are the 3 formulas we can use for projectile motion. Okay, so at first, to find the VF, we used VF equals VO plus AT. And then we plugged in VO is 0 meters per second. Acceleration is 10 meters per second squared. And the time was 0.9 seconds for the ball to fall. So if you plug that in, you get the final velocity to be 9 meters per second. So then you put that back into your XY chart. And since the velocity for the X is always constant, we put that in for the velocity on the X. So now since we have time and we have velocity, we have enough to find out what the delta X was of the ball. So we use delta X equals V bar T. And then we plugged in delta X equals 9 meters per second times 0.9 seconds, and we got delta X to be 8.1 meters. So basically the ball fell, and the X value was 8.1 meters as it fell. Start again.
Hey, Mr. C just sent a remind.
Did you read it?
I'm reading it now.
It says, "Hi physics, when you're done with your video project, upload it and share it to YouTube."
Wait, Mel, isn't World Culture Night on Friday? Don't you have to practice dancing?
I mean, I guess.
We can use that in our project too.
Alright, perfect.
As Melanie begins to turn, her foot pushes and twists off the floor. That initial push creates torque. As she turns, she brings her leg out and slows down. But when her leg goes back into passe, she speeds up due to the rotational inertia.
I'll drink my tea.
Mel, I still don't understand torque.
I can try to explain it again if you want.
Please, I need help.
Okay, cool. The formula for torque is perpendicular force times distance. Since my hand is perpendicular to the object, I'm applying a torque so it rotates. Okay.
Hey Mel, thanks for helping me. What can I help you with now?
Pre-calc, Spanish, 8-push, SAT prep, lunch, physics, English, orchestra.
I think I can help you with this. As you can see in this video, I hit the ball at the bat sweet spot. This is the location of the bat that is generally regarded as the best spot to hit the ball. It minimizes vibration of the bat and results in maximum energy delivered to the ball, meaning it travels the furthest. Hey Siri, how do lights work?
Let me think. Okay, I found this on the web for how do lights work.
I think I can explain it better.
Are you sure?
Yeah.
Come on, Siri.
No, I can do it. There are 2 different types of circuits. There's a parallel circuit and there's a series circuit. In the series circuit, all the resistance that run through the resistors are the same. In a parallel circuit, all the resistance that runs through the resistors are different. Resistance and current are inversely related. The more resistance, the less current, and the more current, the less resistance. Light.
Wait, Mel, but can you help me with the math part of it?
Yeah, I got you.
Thanks.
Okay, so here we have a circuit that is parallel, and the question is asking what's the voltage of voltmeter A. Voltmeter A is right there. So we use the formula V equals IR, and on the picture it says the current was 5 amps and the resistance was 6 ohms. So using V equals IR, we did 5 times 6, and we got 30 amps for the voltage.
Mel, I finally feel better about physics. Thanks for helping me. Now I can work on my research paper, Mr. C.
SAT, woo! Like, that's how you fall.
Hey guys, I'm Zainab.
And I'm Melanie.
And I can't do it.
And this is our physics project.